And I said, I'm not thinking, I'm just following orders. So I sat down and said, all I'm going to do is think about the problem. And what was the problem? The problem was that this bottle wanted to blow into a round shape, right? Obvious to you, right? But what were we trying to do? We were trying to force it into a shape it didn't want to have. So we had to put more pressure. And what were we doing? We are introducing stress. And how many of you guys have done thermodynamics? Do you know what entropy is? You know that entropy can be used for all kinds of things. Did you know that? So what is entropy? Entropy, what? Don't put, stand up and say it loud. Measure of the state of disorder or randomness or something. And if you try to order something, the entropy reduces, right? You want the entropy state to be the maximum. And what we were doing was, because we were introducing stresses, we were making the bottle do what it didn't want to do. And I said, okay, maybe it wants to relax in a slightly better fashion. I don't know if this will work, but we'll try. This is my coffee, but I've been told I'm not allowed to drink this stuff in here, but I'll use it for an experiment. Will someone just check call this guy if this is, oh, it is working. Voila, voila. It is working, it's working. So, in the nitrile case, what we would do is we would take the bottle and dip it in hot oil, because there's something called glass transition temperature, and we had to go beyond, nodding glass transition. What is glass transition temperature, all you smart guys? You guys are nodding. Glass temperature, transition temperature is the point at which the bottle starts to soften. It was about 180 degrees C, so we had to put it in boiling oil, and suddenly this thing would start to take a better rounded shape. And we'd make that shape, and within 2 weeks, we were going up to 4 feet and 5 feet drops. That's all we did. We stopped all this damn experimentation, we stopped all this great computerization and all that kind of stuff, and we started to do this. But when we came to polyester, when we tried to do this, and we'd put this in hot water or something of that sort, it started to shrink. Ouch! It started to shrink. So we couldn't do that. Right? Right or wrong? Yeah, you agree with me? So the first time we did this, shit, it's gone from a half-liter bottle or a 2-liter bottle to a 1-liter bottle or something like that. But we did one more thing which I forgot to mention, which I just do as an aside, is that one day while we were having lunch, we threw this into a microwave. And this started to crystallize. And everyone in the business said polyester is not affected by microwave. And we discovered something that no one knew, and we suddenly had patents on microwaving of polyester, and becomes white. Another thing before I go into how we did this bottle was that this portion, doing it with the wrong thing, this portion is not crystallized, or this portion is not stretched. This is all stretched, biaxially oriented, and this is not stretched. Is not stretched. You understand that? So when polyester gets stretched, it gets some very special properties. It gets permeation properties, it gets strength properties, it gets resistant to chemicals properties and all of that kind of stuff. So we said, we can't do the same thing that we did in the nitrile, so what do? And all we did was blow this thing into a base. I got to reduce, and of course with enough pressure you do it with a lab thing. We could see how this filled, and we started to cut the bases based on how it filled, how it wanted to fill, not how we wanted it to fill, but how it wanted to fill, and suddenly this thing started to work. Except that one day I took these bottles and I was being interviewed by TV, NBC, and I was in their studio, and they're filming me, and I threw the bottle and it shattered all over the place, and the poor hostess had Coke all over her. But that's once in a while. Now it doesn't happen. So that's a very embarrassing moment for me. And so that's how we designed the bottle. We went back to fundamentals and we said, how do we look at things from a fundamental point of view? And what happens is when you have computers and you have all kinds of devices with you, you stop looking at fundamentals because everything is done for you. And my advice is start to think about fundamentals a little bit, okay? Have you understood how we did this process? Right? It wasn't any high tech, it was just saying how can we do this from a fundamental point of view. Are you with me? Okay. So the rest is, I already talked about the two-step. There was a two-step process and a one-step process. In the two-step process, you make there's a machine that makes the preform and simultaneously you go into a machine that blows it. So you never have to cool it down and reheat it. Which one do you think is better? A two-step process or a one-step process? Let's have a vote. How many think the one-step process is better? And how many think a two-step process is better? Okay. Who said one step is better? Come here. I know, that's why I want you here. And who said the two-step is better? Come. So why did you say that one step is?
Okay, first of all, I'm an electrical engineer. I just intuitively felt that one step is better. That's
why?
Because since there is one step, I thought there will be savings of energy.
Right. Absolutely right. And come.
Yeah.
Don't let him get away with it, right? So why was the two-step better?
I thought that because of a second reheating step, there will be some annealing going on. So
okay, no. So the both have their place. He's right. The one-step process uses less energy. But what happens in a two-step process is that you can't really balance, in a one-step process, you cannot balance the injection cycle, which is 30 seconds or so, with the blow cycle, which is 3 seconds. So your blowing section is idling, right? Whereas in the two-step process, both are working optimally. Please, thank you. So, there's, and oh, you said savings of energy. Smart ass. I mean, look at that. I was so impressed by you. Okay, I'm not going to waste time on why, which. So we want to look at fundamental solutions. Do not discard initial ideas due to cost. Remember, you will become smarter with time and cost will go down. We overestimated the near term and we underestimate the long term. So now we are ready, right? We've got a bottle that works. So what do we do next? We send 1 million bottles to a filling line to check if they fill properly. And you remember that, like everything else, when you start off, what were we replacing? We were replacing a glass bottle. So the filling lines were designed for glass, which is heavy. And suddenly we're putting this plastic thing there. And we had a lot of problems. We had to modify the filling lines. And when we did that, the run went off very well. So I came home on a Friday night feeling very pleased with myself. We filled 1 million bottles and everything is perfect. God's in his heaven and let's celebrate and all that. Monday morning, the Coke plant manager calls me and he says, your bottles are leaking. Bottles are leaking? So I said, are they leaking from here? That's the only place they can leak, right? Right? Huh? Nothing. Why would it leak from the bottom? No, there's no hole. But in point of fact, it was leaking from the bottom. Now, what I told you that these areas were not stretched, right? They were still non-stretched areas, and so they didn't have chemical resistance. And on the filling line, they used to use some kind of soaps or they used to call them detergents, with some chemicals in them. And those chemicals, unknown to us, were starting to attack these. So now we have to find out which chemical has to attack it, and the long-term things, it takes months and months, and everything is shut down. The plant can't operate. And who's holding up the works? Yours truly. So here I was stuck again. And then that evening or the next evening, I saw this ad which Nacha has probably seen. Ivory soap, good for a baby's bottom. So I said, shit, if it's good for a baby's bottom, it's like hell, it must be good for my bottom. So we went back to those guys and said, can we put Ivory soap on the filling line, on the conveyors, so that we'll get soap on the line? They said, sure, why not? And it worked. And so we were back in business. What I'm saying is just simple things. And then when we did all this, all the diversities and all the companies that make lubes, and they came and started doing research and all that, which was fine by us because we were happily working with Ivory soap. Then we had two problems after that. So life is not simple. It's like having 5 quizzes. You do the first 2 and then the third damn quiz comes up, So we've done all this crap, and suddenly what happens? What happens? So, number one, Coke marketing started and Pepsi marketing started to say, we would have 30% of the market, right? And competition would have 70%, or we would have 70% and there would be a second supplier with 30%. Their bottle looks different from ours, right? Because they've got a cup. So they said, we can't have this. We can't have a 1-piece bottle and a 2-piece bottle side by side. Make sense to you? Right? Doesn't look good on the shelf. And so we were then in a dilemma. What do we do? How many of you guys have heard of VHS tapes and beta tapes? 1, 2. Oh, this guy. 3. So there were videotapes that came out maybe 20 years, 30 years, 25 years ago, right? 30 years ago. And the beta was a much better format. And the VHS was not such a good format. But what happened was that VHS won out. Beta, even though it was better, got lost. It's like the Apple computer. How many of you use Macs? How many use Macs? No one, except for 2 guys. And how many use Windows? Everyone, okay. So, but you know from Mac users that the Mac is a much better machine and its software is much better and all of that kind of stuff. But the Mac is a captive thing to Apple, whereas the Windows can be put onto any computer. So here we were being told maybe you guys should also go to a two-piece bottle, and then we did a very smart thing, I think it was a very smart thing. We found a Coke bottler. A Coke bottler is a guy who bottles this, puts stuff into it, and I said, do you want to go into self-manufacture? We'll help you go into self-manufacture. We'll help you make these bottles. And you know, once you're inside the Coke system, you know, a Coke bottler, they treat him much better than they treat a supplier because they're part of the family. And so they loosen a lot of specs. And the moment we did that, and we licensed a guy in the UK, suddenly everyone wanted only our bottle. And when this happened, this was 1973, 1983, and by 1986 the patents were going away. So the whole market went to the one-piece bottle. And that's all you see today. Okay? Then suddenly they said, you see what happens is when you blow a 2-liter bottle like this, the stretch ratio is quite a lot, right? And it can become really light and it can really become very competitive. When you try to do a half-liter bottle, the stretch ratio is much less, right? You can see that. All of you can see that? Much less, so the strength is much less, so you've got to use more material. Now what was happening at that point in time was that there was a bottle called the 16 ounce, which is about half a liter, 16 ounce Plastishield bottle, which is a glass bottle with a styrofoam label on it. And glass had done a tremendously good job, but Coke said we want, and Pepsi said we want a half-liter bottle. So I was appointed the guy who was going to make the half-liter bottle happen. To cut a long story short, we did make the half-liter bottle happen, but what happened was that our bottles were selling at $105 a thousand, and the glass bottles were selling at $95 a thousand. And at some places, glass was selling at 85. We felt we could come down to 95. The question was, could we really compete with glass? So, since I was the guy in charge of all of this, I went and asked the can guys, I asked everyone I could, what do you know about the economics of manufacturing glass? No one had thought about it. No one wanted to know, no one had done work on the competition. Now, one of the things that was happening was there was such a great pull for the half-liter bottle that I was actually allocating. So I'd come to the office at about 8:30 in the morning, I'd allocate till 10 o'clock, you can have 500 million bottles, you can have 6 million bottles, you can have this and all that. And then at 10:30 I'd start to say, whom should I take out for lunch? And then after lunch I'd say, where am I going to play golf and with whom? If you do that for a week or you do that for 2 weeks, it becomes boring, you know. You can't keep recycling the same old guys for lunch. I mean, so I said, let me find out what the real economics of 16 ounce glass is. And I spent the next 2 or 3 months going all over the world, really understanding how 16 ounce glass was manufactured, what its manufacturing economics were. And I came to a conclusion that as the marketplace expanded, they would have to put in new machines. You don't have to be smart to do that. But if they put in new machines, they would never be able to compete because they'd have to take full depreciation of the new machines. In depreciated plants, in old plants, they could compete with us. So when I left America around 1976, no, 1986, and I spoke at an industry conference and I said, we were at that point selling 1 billion bottles and glass was selling 3 billion bottles, right? I said, in 5 years' time, glass will disappear. And I'm back in India. And of course, everyone laughed at me. Desi aadmi bol gaya. 5 years later, we were at 3 billion units. They were at 8 billion units. And a couple of guys called me, ha, bada acha, bol gaya. 1 year later, glass exited. So I was off by 1 year because they just couldn't compete. They were losing money, and the only reason I could predict that was because I knew exactly what was going on. Now, there were a couple of other things that also happened. Our machines, because we used to do the one-piece bottle, you needed 30 bars of pressure, 30 atmospheres, whereas for the two-piece bottle, you only needed 4 or 5 bars. So machines were starting to wear out. So our engineers came up and they said, each machine, you have to spend $100,000 to get these machines into whack, and they'll last for a long time. And I was asked to do that. And I said, bullshit, $100,000, are you crazy? We had about 45 or 50 machines. I mean, that's $5 million at that time. So we again went back to basics and we started to figure out what was really causing this, and we fixed each machine for $6,000 versus 100,000. And again, everyone said, we're telling you this is the way to go, this is the way to go. I mean, okay, that's a perfect solution, but you can do, we put shock absorbers and we did this and we did that and everything worked out. So all I'm trying to tell you is, just don't think of the best thing. There was a young entrepreneur, I don't know if he's here, who met me, you're here. And I said, don't look for perfection. The other thing I said to him was that when things are happening and you're trying to get incremental results or incremental reduction in cycle times and things of that sort, you can't think beyond that. So we had, at the time that this bottle was being made and when I left, we had a 6.8 second cycle time to blow this bottle. And our goal was to come down to 6.5. From 6.8, we couldn't do it. And I wrote a note saying, what do we need to do to get to 4 seconds? Guess what happened? I was the laughing stock, right? We couldn't do 6.5, and here's a joker saying we can do 4. And you know what the cycle time is today? Any guess?
1,000 bottles per minute.
No, 3 seconds. I said we could go to 4. People laughed at me. Today they're doing 3 seconds. So what happens over a period of time is that you get smarter and you can do a whole lot of stuff. And I'm going to sort of stop here because this is, so this is the petaloid base. These are some of my patents. This patent I'm very, very proud of. It has ribs in the preform and it blows a ribbed bottom, and we use this for tennis ball cans. And then I decided, why don't we make a bottle with an integral cup in one go without having to put a second base cup on. And then I invented a 2-walled bottle, which is not made by 2 bottles being put into each other, but by making a preform that had 2 walls, which was made in one step, and just you blew it into a bottle with 2 walls, which you can use for, for chemicals, or you can do all, there are hundreds of uses for it. So, and then, much before all this happened, I invented noise control kits And if you see generators and all that kind of stuff, they're an offshoot of these patents. All the generator housings, they're an offshoot of my patents. So this is, I can proudly show you my name. And then I did a whole lot of stuff in plastics and in plastics forming and all. I don't want to go into it. And now I do something called customer value management. And I do value creation, and I'm trying to get a value creation center started at IIT Madras. And that's all I have to say. It's another one of my books. And thank you for being a good audience and for saving my neck and not drinking the Coke. Any questions? Sir? Experience by having the pressure has to be within a particular band. So that's number one. Number two, you can increase the pressure in any of these things by increasing the weight. The weight of these bottles is something like 60 or 55 grams today, and the weight of a glass bottle is almost 700 grams or 600 grams. And the real problem was a 2-liter glass bottle, when it was put in the sun, it would explode. Customer value, we help people create value. We help people think about the customer, and we help people to think about value creation. And value creation is going the extra step. So I tell people that if you all of you have teachers, if you have professors who teach you, the professor who adds value to you is not the one who just gives you the knowledge, but the one who tells you how to use that knowledge really creates value for you. Do you understand that? So if you not only get the knowledge, but you know how to use it, it's much more useful. Yes, sir. Ma'am, I'm sorry.
Sir, replacing glass bottles with plastic, hasn't it caused a lot of environmental damage? And disposability is an issue with plastic bottles, don't you think? And glass bottles were used to be, they were reused. And completely replacing them with plastic bottles, hasn't it done a lot of environmental damage?
So, what's your name?
Padma Priya.
Padma.
Padma Priya.
Padma Priya. Padma Priya, I've got to speak from both sides of my face now. Okay? One side is the true packaging professional who says all this is what you said was bullshit. But the truth of the matter is that you have plastic bottles, particularly in Europe, that are refillable. Okay? Secondly, typically one plant would require the energy that would be taken by a 747 to fly from New York to San Francisco and back. So, there wasn't all of that. But, there's this dilemma. The second side of my face says there's this dilemma that when you're in the packaging business, you're thinking about convenience, and therefore you're thinking about throwaway stuff. And there's so many throwaway stuff. So even your coffee was in a cup and all that. It's not right. But it's one of the prices we pay for progress. Have I answered your question?
So what do you think would be the closest substitute that will not environmentally damage but still will
So
be
the
as...
best is, you go to Mother Dairy to get milk, and you take your own bartan, and you put it underneath and you take it back. Why can't we do that? But we're too lazy. Convenience sells. And when we talk about customer value management, one of the things that customers look for is convenience. They don't want to waste time waiting for the guy to give the change. They don't have, they want everything to happen instantaneously. Anyone else? Yes.
Now what polyethylene, acrylate, right?
Yeah. That's PET.
I was just going to say, I'm a classmate of Gautam's, and I come from the medical device industry where a lot of plastic is used. Plastic, I think if you utilize it properly and recycle it properly, has significant advantages. If you look at polyethylene terephthalate, for example, there is what is called a medical grade PET, which is what is used in balloon catheters to open up coronary arteries and so on, which is what I have worked in. But there's PET 1 to PET 7, I think. So each time you recycle, you make it into a lower grade PET, so that you are not, I think the problem, those of us who come from abroad here, one of the things that baffles me is the amount of plastic along railway lines, Everybody is just dumping plastic. So all of you need to get more involved in recycling in your neighborhood or whatever. Plastic can be used in numerous ways, and glass has its own problems. I don't know if any of you know, there is an Indian beer called Kingfisher, which I think belongs to Vijay Mallya or whatever. He started exporting Kingfisher beer to the US, bottled in Indian plants, and numerous bottles were found to have glass chips in them. And so glass is, especially when you go through packaging and so on, glass tends to chip and can create a far greater problem from a consumer's point of view than does plastic. So I think
I just paid him to talk about plastic being better.
No, but
See how effective I was?
I think the point here is that irrespective, I spent 6 months in a village in 1952-53 living with my grandparents, and at that time, I was 6 years old, we created no garbage whatsoever. We ate on banana leaves, the banana leaves were thrown out, the cows ate the banana leaves, they created manure that was, today in the same village, every drain is clogged with kurkure packaging. I don't know, this kurkure seems to be the hottest snack around. The entire drainage system of the village, which has 6,230 people, is clogged with plastic because nobody has educated people on how to recycle plastic and use it. Now, I don't know if IIT Madras was involved. Somebody told me that a lot of this plastic can be ground up and used in road construction. MIT, yeah. So there are lots of things that can be done. So if you ask me, I would say plastic has done a lot, particularly in the medical device industry. Majority of the products today won't exist for bypass surgery and so on if we were not able to use polyethylene terephthalate. It's an excellent material, isn't it? Withholds some pretty good pressures. Typically a balloon catheter in an angioplasty requires 10 to 12 atmospheres, which is about 150 pounds per square inch, which is a lot more than what your car tire has. And it's a magnificent material. So I think as you go on in your career, I think the key thing is to not worry about the material as much, but worry about how it can be recycled. Then ecologically you are definitely solving a problem. Glass has its own set of problems, trust me.
Yeah, sure.
Thank you.
Any other questions? You're the guy who said energy, and I thought you were smart.
Yeah, sir, I was saying, how do you go about doing something when everyone around you is advising you against it?
So you have to be from IIT Madras to be that crazy. There's no other reason for doing these things. I mean, you have to stand up with for what you believe. And, I did another thing which has nothing to do with this. When I left, I signed a contract for polystyrene at 34 cents a pound when the going rate was 33 or 33.5 cents a pound, 33 cents a pound. And I left. And they said, Sala kha gaya paisa. Desi aadmi, paisa kha gaya. 6 months' time, the prices of styrene went to 65 cents a pound. And we were the only ones in the industry getting it at 34 cents a pound because they felt so good that we gave them 1 cent a pound more when no one was willing to give it to them. So when we were the last people who got a price increase. And then they would all call and say, how did you have the foresight? So you got to do, sometimes you have to go out on a limb. You have to believe. You first have to understand what is really going on. You really have to believe in what you're doing. And then, when I started to do this glass study I showed you, a barrel of oil was $35 a barrel. And there were people who were talking about it going to $150 a barrel. I'm talking about in the 70s. And what we found was it wasn't going to happen. And everyone said, you're foolish, it's going to go. But it remained at about $35, $50, it fell down. And so you know, we were correct, but no one believed us. So you just have to take a chance. I mean, partly it's being foolish, but partly it's being smart, I guess. Anything else? Okay, sorry we went over 2 or 3 minutes, but. And thank you for being a good audience.
Can I ask his batchmate, Mr. Nayanasamy, to handle a small moment?
Really deserve this. What the heck? I need a picture with this. Yeah, we won't get the schools in practice, so noted for a long time. Great, thank you.